This is Algebra 2, Lesson 75, Arithmetic Sequences. Is this the right lesson number? Is this the right order? 75? Right?
Yeah, 75.
Okay, good. We're talking about arithmetic sequences, so we're going to the next unit of study, which is sequences and series, and I'm not going to go into specifics of what that means. We're going to look at it as an individual level, but the basic concept here is we're looking at patterns in math, and we're asking ourselves, or we could make predictions when we see patterns in numbers, when we have a sequence of numbers, okay? So, for example, here's a simple one. Tell me what the next number is in the sequence. 2, 4, 6, 8, 10. How'd you know that? It's going by twos, right? So that's the concept, right? That's how easy it is, right? Or 5, 10, 15, 20, 25, 30, right? You could predict that. Now, what if I wanted to predict the order of the numbers? I was like, well, if I were to write all the numbers out, what's the 99th number going to be? Am I going to write 5, 10, 15, 20, 25, 30, 99 times all the way to number 99? No, that would take a lot of paper and writing, right? So there's a way to do the shortcut. So that's the goal for today. That's the concept. We see the pattern, and then we could apply the pattern and use this formula to find the answer, okay? The steps for the first section of this lesson is here. So if you're on the video, please pause. I'm going to move on. So I'm going to show you how to do numbers 1 and 2. The first thing we need to do is identify if it's an arithmetic sequence, which means does it have a pattern, okay? And is the pattern consistent? That's what we're asking right now. So if a sequence is arithmetic, we need to figure out, is it being added by the same amount every time? So to go from -4 to 96, we're going to ask ourselves, what am I adding to -4 to get 96? Well, I'm just going to take 96 and subtract -4 from it, and the answer is 100, right? So to go from -4 to 96, I'm adding 100, right? And then to go from 96 to 196, I'm adding 100 again. And to go from 196 to 296, I'm adding 100, right? So since I'm consistently adding 100 every time to each number, and by the way, these 3 periods at the end, what this means is we're assuming that this pattern goes on forever. It continues, okay? Does that make sense? So back to arithmetic sequence. These are being added by the same amount every time. Since they are added by the same amount every time, we could assume this is an arithmetic sequence. So we will say yes. This is an arithmetic sequence. Okay? And we want to know, why is it an arithmetic sequence? Well, we need to figure out what's the difference or the amount that's being added every time. So the difference that's being added every time is 100. So that's the other value. Okay? That's the common difference. Okay, 100. So that's how you do number 1. Now number 2, I'm going to do this again. Same steps. We're just identifying, is this an arithmetic sequence or not? Okay? So I'm looking at the pattern from 4 to 7. I'm asking myself, what am I adding to 4 to get 7? Well, I'm adding 3. From 7 to 12, I'm adding 5. And from 12 to 19, I need to add 7. Okay? You follow me so far? Is there a pattern? Yes or no? Yeah, there's a pattern. It's going by twos, right? It's all odd numbers, right? But is it an arithmetic sequence where it's being added by the same value every time? No. So even though there's a pattern, that's okay. It's not arithmetic. So we would say, no, this is not an arithmetic sequence. Okay, and that's it. All right. That's how you do numbers 1 and 2. Again, the goal is finding, is it an arithmetic sequence or not? Okay, so since Monday, let's have 1 still 2 is about number 1. Okay, again, we're trying to figure out what if this is if the sequence is arithmetic or not. Okay, so 40, 20, 0, -20, And then we got 3 periods, assuming that this is going on forever. So first thing we want to do is, we're doing this one together with Mr. Wrinkle. Okay, so start with the first term, and you're asking yourselves, what are you adding to 40 to get to 20? I'm adding negative 20, right? I'm subtracting 20, so. And then what am I adding to 20 to get to 0? Negative 20 again, right? And what am I adding to, oh, not negative 2, negative 20. What am I adding to 0 to get to negative 20? We're adding negative 20 again, okay? So we have 3 times we're adding negative 20, okay? So is it consistently being added? Yeah. So this is arithmetic, so we'd say yes. Okay. And then we would say our difference is equal to negative 20. Okay. Number 4. Let's have you do number 4 by yourself. I could clearly see that there's a pattern here. I could predict the next, 20 numbers, right? Can you all see a pattern here? Okay. Now, but the question is the sequence arithmetic? Okay. Ready? I'll give you about 30 seconds to tell me. Okay. So on number 4, even though there is a pattern, we know that they're just adding a 3 at the end of each term. 3, another 3, another 3, right? To go from here, it's about 1,600. We're just kind of roughly calculating, about. And then to go from here to here, you're gonna have to add like 16,000, right? That's not the same already. So we could already assume they could say no, this is not arithmetic. Okay. All right. So that's how you do the first part of our lesson for today. Now we're gonna go to the next part. So please write down this slide for me if you're on the video or in my class right now. This is the second part. So in this next part of the lesson, now we're going to think, remember how I said what's the next number in this sequence? 2, 4, 6, 8? 10, right? Or 5, 10, 15, 20, 25, 30? 35. Okay. Alright, so that's what we're doing right now, right? Now we can do those quickly in our head, but the difference isn't always the same. Sometimes it's nice and clean like 100, but what was the last problem? The last problem was, what was the difference? Yeah, like 1,600 or something, and okay. Sometimes you need that, okay? For example, maybe you might be in an accountant. Anyone want to be an accountant one day? Or in money? No one wants to be an accountant? Really? Oh, that's too bad. Accountants make good money. Okay, so let's say you were running a business or your own business. You're like, oh man, every day I'm losing $1,614, and I need to know how many days I have left until I run out of money, right? So 15 days until I start making a profit, right? Again, because whatever reason. Like, I wonder how much money I'm going to lose in 15 days. You could predict that using this, okay? So let me look at number 5. I'll do number 5 for you and number 6, and then we will do a couple together. So number 5, the directions say find the common difference. We already know how to do that. We need to find the term named in the problem, so I'll explain what that means. And then the third thing, we need to find the explicit formula for the problem. So we're not going to go in the order that's stated up there, but we're going to go in a different order. Just intuitively, we need to start with step 1, which is figuring out, is this an arithmetic sequence or not? So the first thing we want to ask ourselves, looking at our numbers, we got 3 to -4, -4 to -11, and -11 to -18, and then there's 3 periods here, signifying that this sequence goes on forever. Okay, so from 3 to -4, I'm going to subtract 7, right, to get that. And from -4 to -11, we're subtracting 7, and -11 to -18, we're subtracting 7, right? So we know this is an arithmetic sequence, right? So that's good. So the next thing I want to do is I want to figure out what my explicit formula is, okay? So this is in your steps. We need to write this down. A sub n is equal to A sub 1 plus the quantity of n minus 1 all times d, okay? So A sub n is the actual term I'm trying to figure out. So in this problem, it's asking me, what is the 27th term? If I were to write all these numbers out 27 times, all the way to the end, what would be the 27th number in the sequence? So A sub 27 is good. We're going to write that down right here because we're trying to figure out what's this term going to be. A sub 1 is the first term in our sequence, so the first number in our sequence is 3, right? So we're going to write down 3, put the plus sign down, open parentheses, we have n minus 1 times d, so n in this case, we have a sub n, so n is 27, right? So we're going to put 27, and then minus 1, and we already know what the difference is. We said d is equal to negative 7, right? We're going to multiply all that by negative 7. Alright, because we know that it was d was negative 7 up here. Okay, now we're just going to work out our numbers on a calculator, evaluating this using PEMDAS, right? Parentheses, are they in any parentheses? Yep, 27 minus 1 is 26 times negative 7. Over here we have 3 plus this. Okay, and we're going to, we have to ask if there's exponents. There aren't. Multiply 26 times negative 7, so pulling out my calculator. We have negative 182. Bring down the plus sign. We have 3 plus negative 182, which is going to be equal to negative 179. So what this is saying is that the 27th term, if I were to write down all the numbers, this is the first term, second term, third term, fourth term. If I were to keep writing them, the 27th term would have been negative 179. Does that make sense? Okay. So this is going to save you time in some applications. Or another example is this. Okay. How would this work out? Let's say you had $3 in your name. Okay. And this is what a lot of adults do. They don't even realize how much money they're spending. Okay. They're like, beginning of the month, I only have $3 in my bank account. And they're like, oh, that's not good. But they don't really think about it. Every day they go to lunch, they spend $7. So how much money will they owe at the end of 27 days? At 27 days, they're going to owe negative $179 on their credit card. Right? Does that make sense? So that's the application of it. That's one application you can see. All right, so the tip or the lesson of the day is bring your lunch from home. Yep.
So when we start substituting in for A1, is it always the first number?
Yep, A1 is the first number. That's correct. Yep, because A sub 1 is the first number. A sub 27 is the 27th number, right? Does that make sense? So 3 is the first number, yeah. This is A sub 2, right? This is A sub 3, A sub 4. We have A sub 5. We could predict what that could be, right? All right, let me do number 6, and then you could talk to your neighbor about it. Number 6, we got 40, 36, 32, 28. So first thing I want to do is see if it's an arithmetic sequence. So from 40 to 36, I'm subtracting 4. From 36 to 32, I'm subtracting 4. From 32 to 28, I'm subtracting 4. Okay, so that means that this is an arithmetic sequence, and so our difference is negative 4. Every time we're subtracting 4, okay? So starting off with our formula, we have A sub 28. We're trying to find the 28th term of our sequence here. Okay, so plugging in our numbers, we're trying to find the 28th term. Okay, and then I'll set up your problem, then you'll turn your neighbor and compare your answers. So we have 40 plus n is 28 minus 1 all times d, which is our difference, which is negative 4. Okay, so turn your neighbor and calculate this together. Make sure you get the right answer. I'll give you about a minute. Okay, so the answer is negative 68. All right, so I mean, once you get to this point when you set up your equation, it's pretty easy. This is like pre-algebra status, maybe algebra 1 status PEMDAS problem, right? So 7th grade, 8th grade math right here. The hard part is the concept, right? But once you get to this point, if you were to input everything correctly, it's pretty easy. You got parentheses, multiply, and then add, right? Cupcakes, right? Cupcakes. All right, let's go to the next one, number 7. Let's have you do number 7, and then we'll be done. We're not going to do number 8, because I think you're going to get this pretty quickly. All right. Okay, we know that the 38th number is going to be equal to 200. And it's really important that you put A sub 38, because you're saying that the 38th number in this sequence is 200. Does that make sense? Okay, because we're also going to be adding these numbers, which is going to be summation. We're going to be doing summation notation. Okay? Alright, which is a little bit different. Alright, we're all done with this lesson, so that concludes our lesson for today. What I'd like you to do now is turn to your neighbor and talk about these 4 questions. Ready, set, go!